All right, this is SAT Prep Test 3, Section 3, number 12. We're given the quadratic y equals a times the quantity x minus 2 times the quantity x plus 4. In the quadratic equation above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex CD. Which of the following could equal d? So there's a couple different ways to do this. The easiest way to do this is that in this factored form, right, this actually gives you the roots of the parabola. So the roots of the parabola have to be when y is 0, since we know a is a non-zero constant. That's either when x minus 2 is 0, so x is 2, right, or when x plus 4 is 0, which means x is negative 4. So here's the reason that's relevant. Let's go ahead and put, we'll put 0 here. 1, 2, right, there's 2. 1, 2, 3, 4. Okay, there's negative 4. So the middle of this thing, so C, right, so C is actually going to be essentially the average of these two x values, right? It's going to be the middle of these two, and you could figure out that that's going to happen right here, right? You could figure out that if you move 3 units up from negative 4 and 3 units down from 2, you get an axis of symmetry where C is negative 1. That's fine. The other way to do this, right, so the other way to do that is to essentially FOIL everything out, and you could find the axis of symmetry by doing negative b over 2a, which would give you the C value, and that's fine. But again, a little more complicated here, just because it's not really worth FOILing this out. So my axis of symmetry, wherever the parabola bends, whether it's a smile or frown, has to look like this. Once I know that C is a negative 1, right, I'm asked to find the value of d, right? Well, that means that the point negative 1 comma d is on the parabola. Once I know that, I could just plug in negative 1 comma d. So d equals a times, when I plug in a negative 1, I get negative 3, right? When I plug in a negative 1, I get 3, right? So d is a negative 9 times a, and that's all they wanted, right? And that's my answer, which is d is a negative 9 times a. Again, there are probably other ways to do that. The other things that I can think of, so this is, in my brain, this is the best option, right? So some other options that you could possibly try, right? So we have a times the quantity x minus 2 times x plus 4. I suppose that you could FOIL this all out, right? So you could make this an a times x squared plus 2x minus 8, right? Which make this an ax squared plus 2a x minus 8a, right? You could do that, right? And then the axis of symmetry, so this is your a, right? This is your b, and this whole thing is your c, right? In ax squared plus bx plus c, right? The axis of symmetry of a parabola happens when x equals negative b, meaning negative 2a, right, over 2a, which is how I could get negative 1. So that tells me that the c in the point CD is negative 1, and then I could go back and reverse engineer it the same way I did, where I plug in that value, negative 1 comma d, and find d. I think the other way they trick you here is by using c comma d as the vertex. We're used to seeing that as h comma k, and by using c, I think that can throw a little bit of chaos in the mix, because this is not the same c. Like if I use this y equals ax plus or ax squared plus bx plus c, it's a different c, right? It's referring to a different thing in this situation than the c in this exact problem, and I think that's one way that they try to trick you a little bit.